Still only 27 students have joined. I will wait for another 2 minutes. Okay, I think it is time to start the class. In the last class, I have actually explained the basics of laser action, and there are three ways in which radiation interacts with matter. One is whenever radiation interacts with the matter, induced absorption may take place, or stimulated emission will take place. Okay, and spontaneous emission is the natural process that is also going to occur. Okay, these are the three processes when radiation actually interacts with the matter. And later I have discussed about the concept of energy density of a radiation in terms of Einstein coefficient. Okay, this also has been done, and I have also said this is a very important question. Okay, expression for energy density of a laser in terms of Einstein's coefficient. Okay, I hope you have tried this in your home, and I have already mentioned this is very likely to be there in the second internals. Okay, today I will discuss two minor concepts of laser. Okay, and they will weigh 4 marks. Okay, they will weigh only 4 marks in the examination. They may be there or they may not be there. Okay, the first concept is we have to summarize, or we have to collect how many instruments or materials to construct a laser. That is the first question. Okay, suppose if you have given a task of constructing a laser, then what are the requisites to do that? That question we have to answer. Okay, there are three important components of a laser actually present now. The first component is the excitation source. Okay, excitation source. Excitation source is nothing but a source which actually makes the atoms in the ground state to move to the excited level. Okay, that is the meaning of excitation source. That is very much required. And the second material you require is the active medium. Active medium, or you can say this is the material which actually absorbs the radiation and emits laser. Okay, active medium is the material. For example, if we have a carbon dioxide laser, here carbon dioxide itself is the active medium. Okay, and the last component of the laser is the laser cavity, or I can say it is the envelope, or it is the vessel in which we fill the active medium and we actually perform the action of laser emission. Okay, these are the three materials which are prerequisites for a laser system. Okay, there is a very similar question which may be also asked in the examination, where you have to write the condition for laser action. Okay, students usually confuse themselves with the requisites and the between the requisites and the condition for laser action. Okay, I will go to the conditions later, but keep it in your mind that requisites are nothing but the materials required to construct the laser. There are three important materials. I'm once again stressing the point. You require a excitation source, you require a active medium, and you require a laser cavity. Okay, let me explain one by one. And again, I'm saying these requisites will be asked for 4 marks, and conditions also will be asked for 4 marks. Okay, the students will actually swap their answers. They actually write the condition for requisites and requisites for condition. That will earn 0 marks. Okay, please be careful. Requisites means the materials required to construct the laser. Let me explain one by one. The first one is the excitation source. Okay, excitation source, it provides energy to pump the atoms to the higher energy level. Okay, uh, if we use the light as pumping device, or if we use the external light source to pump the atoms or to excite the atoms from the ground state, that type of pumping is known as optical pumping. Let me repeat once again. If I use a external light source, okay, using which I am going to excite the atoms from the ground state, such type of pumping is known as optical pumping. Okay, and I can also use electrical energy to pump the atoms from the ground state to excited state, and that type of pumping is known as electrical pumping. Okay, in the electrical pumping, what we do is we insert cathode and anode into the laser cavity. Okay, and I hope you remember what is laser cavity. Laser cavity is the envelope or the glass vessel into which we actually fill the material needed to be excited. Okay, and if we introduce two electrodes, that is cathode and anode, inside this laser cavity, when I apply very high voltage, electrons from cathode start to move towards anode. While moving, they will hit with the active medium, and the atoms of the active medium will be get excited. Okay, in this way we can excite the atoms using electricity. Therefore, this is known as electrical pumping. Okay, either way we require a excitation source. Okay, this is a prerequisite. If in a project you are asked to construct a laser, you first have to bring a excitation source, either either the pair of electrodes or a light source. Okay, and then the next important thing is the active medium. Active medium is the material which is actually filled in the laser cavity. Okay, for example, carbon dioxide, and it is actually bound between two mirrors. You can see here in this diagram, these two are the mirrors, and the active medium is filled within this laser cavity. Okay, this entire rectangular thing is the laser cavity, and within which we actually fill the active medium. Okay, the next thing is the laser cavity. Laser cavity is the this envelope. Okay, the length of the laser cavity is designed according to uh, I mean, you just see here, you have a mirror which is fully silvered at the one end, and one more mirror which is partially silvered at the other end. This light which is emitted by the active medium now moves back and forth within this laser cavity. The light will get reflected by the mirror 1, and then it will partially reflected by the mirror 2. Okay, and some amount of the laser light will be emitted out. Okay, the partially silvered means this mirror here at the right hand side will emit some of the laser, and it will reflect back some of the laser. Okay, that is the meaning of partially silvered mirror. Now this length between two mirrors is to be adjusted in such a way that, suppose there is a light which is coming towards right, and it hits the mirror at the right hand side, and then that reflected beam should move in such a way that both these light rays, which is moving towards right and the one which is moving towards left, should constructively interfere. Okay. I hope you know what is the meaning of constructive interference. Constructive interference means the crust of light moving towards right should match with crust of light moving towards the left. Then the amplitude will become more. Okay. This require is very, I mean, this condition is very much required. Sorry, I am getting a call. Wait a minute. Hello. Class ಇದೆ ಆಮೇಲೆ ಮಾತಾಡ್ತೀನಿ. Now, I mean, we have to make sure that we decide the length of laser cavity in such a way that both these lights will interfere constructively and we will get a laser light. Otherwise, what may happen is the light which is reflected by the left hand side mirror may coincide destructively with the light coming from the right hand side and we may not get any light. Okay, I hope you remember what is the meaning of destructive interference. Crust of one light when falls on the trough of the other, intensity goes to 0. Okay, that should not happen. Okay, in keeping that in mind, we have to design this laser cavity. Okay, the length of laser cavity should be chosen in that way. Okay, that's it. These are the 3 requisites. Okay, this will be asked for 4 marks. Okay, excitation source, active medium, and laser cavity. And I have also given relation between the length of the laser cavity and wavelength of the light emitted by the laser. Okay, this should be the relation between them. Okay, and therefore, depending on the length of the laser cavity, we can actually calculate the wavelength of the laser light emitted by the laser. Okay, that's it. You just try to remember these 3 things and read once. Okay, let us move towards the condition for laser action. Okay, this is again will be asked for 4 marks. Okay, there are 2 conditions for achieving laser action. One is the population inversion and the other one is the metastable state. Okay, the population inversion means the number of atoms in the ground state must be less than the number of atoms in the excited state. This is known as population inversion. Okay, why it is required? In simple terms, population inversion is nothing but the state at which the higher energy level is occupied by more atoms than the ground state energy. Why this is required? This is required because if we have more number of atoms in the higher energy state, we will have more and more stimulated emission. Okay, the higher energy state atoms will come back to the ground state by emitting laser light. To meet with this condition or to get more and more laser light, we have to achieve population inversion. If there are more number of atoms in the ground state, then you have to forget about the stimulated emission, right? To achieve stimulated emission, we require more number of atoms in the excited state. That's it. How this can be achieved? That is the next question. Okay, that will be answered by this concept of metastable state. To achieve this population inversion, we have to use materials which will have metastable excited states. In the last class, I have said there are 2 types of excited states available. One is the ordinary excited state and the other one is the metastable excited state. Okay, ordinary excited state will have the lifetime of the order of nanosecond. Okay, and these I mean the atoms which are excited to the ordinary excited state will come back to the ground state very immediately, so that we cannot perform stimulated emission. I hope you remember what is stimulated emission. Stimulated emission is the process in which we make use of a photon to bring the atom from the excited state to the ground state. Okay, to do that we require time, and ordinary excited level is a very short lived level of the order of 10 power minus 9 second, and we cannot achieve the stimulated emission. Therefore, we have to make use of certain materials or molecules which will possess extraordinary, I will call extraordinary excited states, which are known as metastable states, where the atoms will stay for millisecond. Okay, 10 power minus 3 seconds in that level. You may actually wonder what is the difference. One is actually having lifetime of nanosecond, another one is millisecond. Both of them are very small, but compare between them. One is having the lifetime of 10 power minus 9 second, another one is having lifetime of 10 power minus 3 second. What is the difference? Almost 10 power 6 times metastable state is stabler than ordinary excited state. Okay, therefore it is called as metastable state. Again, I am repeating, metastable state is also a excited state which have slightly higher lifetime, and that amount of energy, I mean that amount of lifetime is sufficient to actually obtain stimulated photons. Okay, this is all about metastable state. Okay, these are the two conditions: population inversion and metastable state are the two conditions for laser. Okay, let me repeat. Requisites are the materials. For example, excitation source, laser cavity, active medium. Whereas conditions are the logics. Conditions are the logics. First logic is population inversion. Second logic is metastable state. Okay, these are the two conditions, and both will be independently asked in the examination. Don't confuse yourself. Okay. Now I will share few animations to explain the things in a better manner. Uh, can you actually see these slides? Slides are moving. If you can see, please raise your hand. Now I am at the induced absorption. Okay, I got it. Thank you. Thank you. Yesterday we have discussed all these things, right? Simulated absorption, spontaneous absorption, stimulated emission, spontaneous emission, and this what do you call Einstein's coefficient derivation, right? We have discussed all these things in the last class. I will want to show a few slides about the requisites and conditions. Okay, this is known as population inversion. You can see ordinary or ground state will have infinite lifetime. That is, every atom on its own will stay in the ground state. Therefore, ground state is the most stable state. Okay, ground state is the most stable state, whereas this E3 here is a ordinary excited state having the lifetime of 10 power minus 9 second, whereas this E2 is the metastable state, and which is having the lifetime of 10 power minus 3 second. Compare these two lifetimes. Okay, there is a order of 10 power 6 seconds between these two. Almost 10 lakh times more stable is this metastable state than the excited state, ordinary excited state. And laser action will take place from metastable state to ground state. When atom returns from metastable state to ground state, laser will be emitted. Okay, now let us move forward. Population inversion also can be explained in this way. We have three energy states. E1 is the ground state, E2 is the metastable state, E3 is the excited state. Here, whenever I use these photons as pumping device, the photons will be absorbed by the ground state atoms, and the atoms will go to the ordinary excited state E3. You can see. Now, these atoms in the E3 ordinary excited state rapidly will fall to the metastable state. Okay, and now we have achieved the population inversion. The atoms in the excited state is more than atoms in the ground state. Okay, this is known as population inversion. Okay, let us move forward. Pumping can be achieved, or excitation of atom can be done using optical pumping method, electrical pumping method, and chemical pumping method. Okay, I mean, here you can see there is a, I mean, this diagram shows the optical pumping phenomena. here we have a external light source, flash tube. Flash tube means it is a light source which produces light flashes. Okay, these flashes will fall on active medium and they will be excited. Okay, this is known as pumping. And active medium diagram already you have seen. Okay, laser cavity, I hope you know. And these are the requisites: excitation source, active medium, and laser cavity. These are the three requisites of a laser. Let us move forward. Now I am moving towards a very important question from the point of view of examination, that is construction and working of carbon dioxide laser. Okay, from this laser module, we have three important questions. One is, of course, expression for energy density, and the other two are construction and working of carbon dioxide laser and semiconductor laser. Both will be there for 7 to 8 marks in the examination. Okay, I will explain few things in carbon dioxide laser in the today's class. Okay, carbon dioxide laser was actually discovered by Kumar Patel. Okay, Kumar Patel of Bell Laboratories in 1963. Okay, this is the actual carbon dioxide laser which has been uh, constructed in Bell Laboratories. Okay, you can see the laser is emitted over here. But you have to understand this carbon dioxide laser is not a visible laser. This is a IR diagram of the carbon dioxide laser. This is actually radiated in the IR region. The laser have the wavelength of 10.6 micrometer. That is almost 10,000 angstrom. 10,000 angstrom means it is not a visible light. Okay, visible range is between 4,000 to 7,000. Okay, between VIBGYOR, I think you know, violet to red. Okay, it will have wavelength between 4,000 to 7,000 approximately, whereas carbon dioxide laser will emit radiations of the order of 10,000 angstrom, which is in infrared region. Okay, I hope you know what is the use of these infrared radiations for night vision cameras. Okay, I hope you have seen the movie Uri, where the army strikes the enemy at night using these IR cameras. Okay, IR cameras were built in the helmets of the soldiers, and I mean wildlife photography can also be done using IR lasers. Okay, IR cameras, and there we actually use these kind of lasers to identify the objects at night. Okay, just remember, IR is not, I mean carbon dioxide is not a visible laser. Carbon dioxide actually gives IR radiations. Okay, let us move forward. I will explain what you have to write for construction and working. These are all just requisites. Okay, now here is a very important question. You have to explain what are the different modes of vibration of carbon atom. Okay, this may be asked for 4 marks. Okay, this is independent of that construction and working. You need not to write while writing construction and working, but this is an independent question. Now we are saying about carbon dioxide laser, then we have to account for these energy levels. I have said active medium is nothing but the material which we use for making the, I mean creating these laser radiations. Active medium is nothing but the material. For example, in this case carbon dioxide. We have to now account for the different energies of this carbon dioxide molecule. Okay, we have to account for the ground state of carbon dioxide molecule. We have to account for the excited states and metastable states in the carbon dioxide molecule. Okay, and you should understand this energy for carbon dioxide, I mean these different energy levels of carbon dioxide molecule actually comes from different modes of vibration of carbon dioxide. Okay, I hope you know carbon dioxide contains 1 carbon atom and 2 oxygen atoms. This is a linear molecule. Here in this linear molecule, you have to identify what are the different types of motions exhibited by these carbon dioxide molecule. Of course, there will be no kinetic energy. The carbon dioxide molecule kinetic energy means one carbon dioxide molecule is moving from one point to other point, which will not give any radiation. Okay, and we get radiation only when this carbon dioxide molecule vibrates. Okay, that is known as vibrational spectra of carbon dioxide molecule. Usually, carbon dioxide vibrates in three modes, and three different modes will correspond to three different energy levels of the carbon dioxide molecule. The first mode of vibration is known as symmetric stretching mode. Okay, symmetric stretching mode, and spectroscopically it is known as 100. And I will not explain what is the meaning of the spectroscopic notation 100. Forget about it. Just try to remember 100 is the spectroscopic notation of symmetric stretching mode. Symmetric stretching mode means this in this mode, carbon atom will stay at the center and both oxygen atoms will move towards the carbon, move towards and away, towards and away. That type of vibration will be executed. Okay, this will correspond to symmetric stretching energy. Similarly, there is one more energy known as asymmetric stretching energy, which will come from asymmetric stretching mode. Asymmetric stretching mode means one atom of oxygen will move towards carbon. At the same time, other oxygen atom will move away from that carbon. Okay, let me tell once again. One atom of oxygen will move towards carbon atom, and the other atom of the oxygen will move away from the carbon atom. This is known as asymmetric stretching. One is coming towards and one is going away. Okay, this type of vibration will correspond to asymmetric energy. And there is one more type of vibration possible in carbon dioxide molecule, that is known as bending mode. In the bending mode, entire molecule bends. Okay, carbon atom will move upwards, then oxygen will move downwards. In the next moment, carbon will move towards down, oxygen will move towards up. This is known as bending mode, represented by 0, 1, 0. Again, I repeat, all these three vibrations will correspond to three different energy levels of carbon dioxide molecule. To understand the laser emitted by carbon dioxide molecule, we have to understand what are the different energy levels of the carbon dioxide. Okay, this question will be there in the examination sometimes. Okay, you have to explain the different modes of vibrations of carbon dioxide molecule. Okay, now the you have to start with the principle. Okay, on which principle this carbon dioxide laser works. Again, it is the stimulated emission. Okay, it is the stimulated emission which will actually give rise, which will be responsible for laser action. Here in this carbon dioxide molecule, nitrogen molecule is mixed with carbon dioxide molecule. Okay, and why this has been done is to achieve this metastable state. The nitrogen molecule will have a energy level. Okay, the ground state of, you just look at this diagram here. Ground state of nitrogen molecule is represented by mu is equal to 0. There is, this is a notation. Okay, and the excited state of nitrogen molecule is represented by mu is equal to 1. Just keep it in your mind. This first excited state of nitrogen molecule is a metastable state. Okay, whereas in the carbon dioxide we don't have any metastable state. Okay, therefore to achieve population inversion, I hope you remember, we require metastable state. Thus we mix this nitrogen molecule with carbon dioxide. Okay, and one more thing is, this metastable state of nitrogen molecule actually coincide with the asymmetric energy of the carbon dioxide molecule. Therefore also we actually mix nitrogen molecule with the carbon dioxide molecule, and what we do is we somehow, by electrical pumping, that is by applying a electric field on either side of the laser cavity, we actually accelerate electrons through this mixture of nitrogen and carbon dioxide molecule. These electrons which are moving towards anode will strike with this nitrogen molecule. Okay, then the nitrogen will be get excited, or velocity of the nitrogen will be increased. Now with the nitrogen atoms which are moving with higher speeds collides with carbon dioxide molecule. Okay, and this carbon dioxide molecule, which is moving initially slower, will absorb that energy and they will go to the asymmetric stretching mode. Okay, and this asymmetric stretching mode carbon dioxide is metastable one now. Okay, the lifetime of this asymmetric stretching mode of carbon dioxide is metastable, sorry, higher than the ordinary excited state. Okay, let me explain once again. I mean, by using nitrogen molecule, we can actually provide a metastable state to the carbon dioxide molecule. Okay, the electrons when hits the nitrogen molecule will get excited, or speed of the nitrogen molecule will be higher. Whenever these nitrogen molecules collides with the carbon dioxide will absorb the entire energy of this nitrogen molecule, and the carbon dioxide atoms will go to the asymmetric energy level. Asymmetric energy level for carbon dioxide is a metastable state. Okay, once you get this metastable state, you will achieve stimulated emission. Okay, this is the principle of carbon dioxide laser. Okay, I will stop right now. I will take the construction and working of the carbon dioxide laser in the next class. Okay, and I will finish up this module. Okay, I will in the next class I will explain construction and working of carbon dioxide molecule, as well as construction and working of this semiconductor laser, and maybe 9 to 10 days will be left for reading. Okay, at least I think 1 week will be left for reading. You have to practice 3 important questions from laser part. Okay, please keep it in your mind. You have to practice expression for energy density, construction and working of carbon dioxide laser, and then semiconductor laser. I think 1 week is enough. Okay, now I will stop the class. If you have any doubt, please ask me. Okay, today I have actually discussed 2 minor concepts, that is requisites for laser and condition for laser. Okay, these are the 2 minor concepts which will be asked for 4 marks, and I have started the construction and working of carbon dioxide laser. Okay, again in that also I have explained a minor concept of different modes of vibration in carbon dioxide molecule. Almost 12 marks questions has been discussed in this class. Okay, if you are not able to understand, please ask me. I will take the class during offline mode, and I have also uploading this to the YouTube channel. If you are able, then you can see them. Okay, thank you very much for participating. Right now I'm stopping the class. Okay, thank you very much. Bye.